Myself, Dr. Aboobacker Sidheeque, Department of Conservative Dentistry and Endodontics, Yenepoya Dental College. Today, I am talking about Endodontic Instruments, Part 1. My contents are materials, standardization of instruments, classification, conclusion. Coming to materials used in instruments. So, initially, we were used carbon steel, then comes stainless steel, then titanium and nickel titanium. In 19th century, carbon steel was used for manufacturing instruments. The main disadvantage of carbon steel was fracture tendency due to brittleness of metal, corrosion along with sodium hypochlorite irrigant during the steam sterilization. In 20th century, stainless steel was used by Kirk manufacturing company. Advantage, it is flexible, hence is likely to fracture when stained, less susceptible to corrosion. The main disadvantage of stainless steel file was canal curvature. That means when narrow canals comes, very difficult to use the stainless steel. So in order to avoid that, nickel titanium was introduced. It contains 55% of nickel and 45% of titanium. The advantage of the nickel titanium was it has good shape memory, super elasticity, low modulus of elasticity, corrosion resistant, and the instruments were very softer, good resilience and biocompatible. Disadvantage of the nickel titanium files were poor cutting efficiency and the fatigue and poor resistance to fracture. The most important is standardization of instruments. Coming to the standardization, Ingle and Levine in 1958 recommended three features. One is diameter and width of the cutting blade, length of the cutting blade and taper of the cutting blade. Coming to the standardization, Ingle and Levine 1959, and it was instruments number 9, there are instrument number from 10 to 100. Diameters were 1 by 100th of the tip. It is named as D1 and D2. Instruments are numbered from 10 to 100. The numbers to advance by 5 units and to the size till the size 60, and then by 10 units by size 100. Each number shall describe the number of instrument in 10 of a millimeter at the tip. Example, size 10 tip is 0.1 mm. The working blade shall begin at the tip designated as D1 and the float extend to the tip 16 designated D2. The taper of the instrument is D2 is increments of point. Every taper will be 0.02 in the width. Other specification are tip angle of the instrument 75 plus or minus 15. The instrument size should be increased by 0.05 mm at D1 between 10 to 60 and then by 0.01 mm 60 to 100 for increased instrument selection. Instruments are available in different length 21 mm, 25 mm, 28 mm, 30 mm and 40 mm. 21 length is used for molars, 25 mm length is used for anteriors, 28 and 30 mm length is used for cuspid. 40 mm rim is used in preparing the canals for endodontic implants. So the most important next topic is most important thing is color coding of instrument. There is a set of colors like white, yellow, red, blue, green and black. Okay, the numbers 6 and 8 is not shown here. 6 number file is pink color and 8 number is grey color. Okay, and the 10 number file is purple color. After that it comes 15, 20, 25, 30, 35 and 40. So white color denotes number 15 size number, yellow means 20 number size, red means 25, blue 30, green 35, black 40. So there is a sequence white to black. So 45 again this comes like white color, 50 yellow color, 55 red color, 60 number size, blue color, 70 green color, 80 black color, 90 again white, 100 yellow, 110 red color, 120 blue color, 130 green color, 140 is black color. So there is a sequence from white to black. So after 40 again this comes like order like white, yellow, red, blue and black, green and black. So for narrow canals we use 6 number, 8 number and 10 number is designated as 6 number is pink color and 8 number is grey color and 10 number is purple color. The modifications of KF files are KF flex files. Length of fluid is 18 mm from the tip to extent, that is D1, D2 are not significant. This recommends use of D0 and D16. AD specification number 28 revision in March 1981 is stated instrument size and number 6, 8, 10, 15 were added to the original standardization and D1, D2 changed to D0 and D16. 6 factors are considered while analyzing endodontic instrument: material that is cut, anatomic configuration of root and material cutting instrument, manufacturing process, grinding and design of the instrument and the fluid used for process. Manufacture of instrument. In early 1990s, the Kirk manufacturing company designed and manufactured new K-type endodontic instrument. Initially, the instruments were manufactured from the round tapered piano wire that is called as carbon steel, but now they are modified to stainless steel blanks. Stainless steel wire is grounded along its long axis into 4-sided square cross section or 3-sided triangular cross section. Tapered shaft that is twisted into fluids extended 16 mm from the top to the tip of the blade. The number of fluids twisted into each blade determines whether instrument is file or a reamer. The file is tighter fluids, reamer is looser fluids. Files mean the fluids will be in tight and reamers with the looser fluids. Okay. Cutting edge is generated by twisting the metal shaft along the long axis by the machine it. When twisted, the square blank produces a right rigid instrument. The triangular shape is flexible, rhomboid shape is more flexible. When machined, the depth of the cut used to produce the fluid designates the flexibility and strength of the instrument. Recently, rhomboidal and diamond shaped blanks are twisted to produce a K-flex to increase flexibility cutting efficiency. H-file manufactured from the round stainless steel wire machined to produce a spiral fluid resembling cone or screw. Unifiles machined from the round stainless steel wire by cutting two superficial grooves produce the fluids into double helix design. Coming to the classification, the last part of the topic. According to Grossman, he divided into 4 types: exploring instrument, instrument used for the debridement, shaping instrument, obturating instruments. Coming to the exploring instrument. Exploring instruments are such instruments to locate the canal orifice to determine or assist the obtain the patency of the root canal. Examples are endodontic explorer and smooth broaches. Coming to the debridement, to extirpate the pulp to remove the cotton pellets or paper point. Example, bar broach. The third section is cleaning and shaping. Examples are reamers. The last one is obturating material. So obturation, we use the gutta-percha. Okay, for condensation of the gutta-percha and to create space laterally. Examples are spreaders and pluggers. Lendular spirals, engine driven and latcher type of the attachment and working portion of the springs like coated with the root canal sealer. The International Standard Organization has grouped the root canal instrument according to their use. Group 1, hand use only, that is file, H-type. Files are 2 types, H-type files and K files. Okay, reamers and files and broaches. Group 2 are engine driven latcher type. So this is a high speed instrument. Same design in the group 1. It has to be attached to the hand piece. Examples are profile and light speed. Group 3 engine driven latcher type. In this group 3 is low speed instrument where latcher type is in one piece with the working part. Examples are glaze grid drill and piezo reamers. Group 4 root canal points, gutta-percha, silver point and paper points. According to the stock, he divided into twisted and machined. In twisted, K files, K reamer, K flex file, flexo, zipper, flex cut. Machine, H file, flexar, canal master, heliapical, flexo, gates and mex pad and engine file. Coming to the international organization or otherwise called ISO, group the instruments to 4 categories. Group 1 is hand use only, Group 2 engine driven latcher type, Group 3 engine driven latcher type and Group 4 is root canal points. You can see the figures. So this is the K type file cross section, K type reamer, K type file, this is H file, R type rasp and bar broach, probe, applicator. Okay. So the difference between files and K type reamer, files and reamers are, you can see the flutes, right? So once the flutes are tightened flutes if you see, that means it is a file. If the tools are loosened, that means it is a reamer. So that is the main difference between files and reamer. Coming to the K file and H file, if you see the file cross section, see, is a screw type, is a rhomboidal. Okay, screw type means, or a Christmas tree pattern means is S file. So flutes are tightened or like rhomboidal shape cross section, that means it is a K file. Coming to the next topic. According to Cohen, hand instruments, those specific to endodontics, an instrument for pulpal space. Okay, it is again divided to group 1, group 2 and group 3 and devices for root canal length measurement, instrument for the root canal obturation, device for removal the root canal obstructions. Coming to the ADA classification, okay, type 1, there are different classification. Type 1, ADA classification type 1 to type 9. Type 1 is reamers, type 2 is files, type 3 is headstone files, type 4 is RAS and type 5 is broaches, type 6 probes, type 7 is applicator, type 8 is condenser, type 9 is spreaders. According to the Hartig classification, for access cavity preparation, he classified into basic instruments, burrs and rubber dam. And next is for root canal preparation, hand instrument, power assisted root canal instrument, electronic canal measuring system, measuring instrument, gauges and stand, instrument for retrieval for broken instruments and paste, instrument for root canal filling. Thank you. Next part I will cover in part 2, that is files, each files, hand instruments and difference between the instruments.